All right, let's get started. Thanks for coming today. I know there's a lot of talks to choose from, and I'm happy to present to you. So I'm Stephen Day, or Stevu. You've probably seen me on GitHub, in Docker, or Containerd, or various places, maybe gRPC or something like that. And today I'll be talking a little bit, just kind of an overview about Containerd, and then hopefully I can give you some pointers on where to go with the project and what you can do with it. And if we have time in the end, I'll do like a couple of little demos and just show you the basics of it. So a little bit of history. So the project was started in April 2016 and was released with Docker 1.11. And so basically it provided like a supervisor or management of OCI run C processes. We wanted to expand the project as of December 2010. And with that, we started the Containerd 1.0 work stream, and which was finalized or released in December of 2017, and then we've recently had a release in December, just a week ago at the end of April, which includes CRI support, and I'll talk a little bit about that. Here's the GitHub URL. Watch out for pretenders. This is the real Containerd. It's Containerd/Containerd. So, and you can go there. Anything you want to talk about the project, file bugs, send us pull requests, complain, whatever. We're willing to take your contributions because that's great. So why did we do this? Why another container runtime? The main issue was the Docker roughly in 2016. The Docker engine was really becoming a monolith, and we wanted to spin things out of there so we could make different components useful without having to stand up the entire Docker engine. We also wanted to have other use cases such as like the Kubernetes CRI. BuildKit, which is another project that does build, as well as other stuff we haven't thought of. So, and we wanted to donate it to a foundation, so with broad industry support. So we have lots of contributors like IBM, Microsoft, Amazon, VMware, and Google, and people from the Kubernetes community as well. Our technical goals were to ensure that we had a really clean gRPC-based API and client library. We wanted full OCI support so that it kind of felt OCI native, works really good with OCI primitives, and they don't feel tacked on. We also wanted to focus on stability and performance with like a really well-defined core and kind of avoid feature creep over time. And part of that was designing it for like decoupled systems. So we wanted the image, the file system, the runtime to be available for pluggability and reuse. So another way of putting that is Containerd is very a la carte. So you can use the whole thing, or you can choose which parts depending on your problem space or what systems you're integrating with. We also wanted to be agile with actual runtimes. So in Containerd, we don't actually touch OCI configs, we just pass them through, which actually means you don't have to do an OCI config on your runtime. You can do other kinds of runtimes that take different configurations. So for example, like Windows doesn't have an OCI config, it has its own kind of configuration. But it also allows us to do things like adding support for Kata containers took no changes in lines of code. We just added it, and it worked because it was run C compatible. And I've already said that part. We do use Prometheus for metrics. I'll mention that. So we actually try to use other CNCF projects inside of Containerd where it makes sense. So again, well, OCI is not CNCF, but it's very closely related. But gRPC for API and Prometheus for metrics. So the kinds of use cases that Containerd fits into is this big umbrella of container API implementations. We can put like Docker Moby under there, Kubernetes CRI, Alibaba Pouch has been cropping up lately. That's kind of an interesting project. And then also like SwarmKit and other stuff. And then the other two big use cases we were looking at, and I'm sure there's more use cases that I've left off of here that people can try out. But building images. This is what BuildKit does. It leverages Containerd heavily and the models and architecture within Containerd, and then as well as container OS. I was trying to generalize basically what LinuxKit is doing. So LinuxKit actually runs its internal services as containers, and this has been a long ask of Docker. It was kind of a problem with Docker because you would start up Docker and try and run system services, and to actually implement that, you'd have to have 2 Dockers. But with the architecture in Containerd, you only need 1 Containerd, and it can run all of these different things on the host. And then there's also like IBM Cloud is an example of a cloud provider that uses Containerd. So there's lots of different use cases. It fits into a lot of spaces because of its flexibility. So a little bit about the architecture. So this is kind of a 3-layer architecture. At the top, we have like what you interact with, being a gRPC and the metrics API. And then in the middle, we have a suite of services that are loosely coupled. And some of them interact depending on what's needed. But we can roughly divide them into 3 parts. There's storage, which is images and snapshot file systems and diffs for building images. And then there's a metadata portion, which declares containers and images and how they relate to other parts of the system. And then there's a tasks API. And the tasks API is the actual runtime the actual runtime manipulation. So, and all of this sits on top of the operating system and then interacts with the runtimes. And then across all of the services, we have an event service. So Containerd can actually, you can consume events, and then you can actually generate events back into Containerd, so that like if you have another component that's kind of outside of Containerd, it can generate its own events, and then you can consume those within another component that you've integrated with. Containerd is what's called a client-heavy architecture, meaning that, well, stepping back, we really wanted to avoid having abstractions that prevented people from doing what they want. This was a huge problem in Docker because you'd kind of squint at people's problems and you'd say, ooh, I don't know if it fits into the abstraction, like I don't know if this is the right way to do it, and eventually you end up with a very inflexible system. But with Containerd, we kind of said, all right, well, let's go down a level and say you can interact with what's necessary in Containerd, and Containerd only provides what's necessary, but then the client can actually integrate with the operating system to provide functionality. So we've worked very hard to build a solid client library to make this a reality, but it means that you can, so rather than building plugins everywhere to add functionality, you can build your own code and do everything you want and then interact with the Containerd abstractions. So here's a couple of links. Take a picture, or you can probably find them with some careful Google foo. But the one on top is a getting started guide. Everything I'm talking about here will be in the getting started guide, and I suggest you go through it if you really want to understand Containerd deeply. And then also the Go-Doc is great. And so this Go-Doc link takes you directly to the client, and that'll be how to implement containers with that. And these examples will all use interfaces that are defined in the Go-Doc. So a little bit about kind of how these services fit together. Like it looks like just a bunch of services. What do they do? It looks really complicated. And so I think pulling an image is a great example. It's a really complicated thing. It's magic in Docker, and recreating that magic and defining the different parts of it is very, very important to a good container system. So the way I like to think of it is this data flow diagram. On the bottom, we have the services, and then the colored boxes are the like client-heavy implementation, and then we have our goal at the end, which is mounts. And mounts are just things you pass to the container to make up the root file system. So to run a container, your goal is to get a root file system. And so you say, when you say pull, you're going to start doing two things. Your first operation is going to be to fetch the image data from a remote, register it with the content store, which is where we securely store all of the image metadata, all of the image layer files, manifests, manifest lists, etc. And then we register that with the image store. So that's just a link back to that. And then we also do an unpack process. And so what that'll do is take the content, such as a layer, and then it'll apply it to a model we call snapshots. And snapshots, what they do is provide something similar to what's in graph drivers. And this gives you the ability to have kind of a revision container file system. And I'll talk a little bit about that later. So the snapshotters are, who's familiar with graph drivers? Like, just share of hands. Okay, so so snapshotters is so I won't explain it based on graph drivers, but snapshotters are just a way of saying I have a base layer, and then I have a set of change sets on top of that and how they relate to each other. And so it lets you build up a root file system from that. And the architecture is relatively simple. All you have is a metadata store that contains references into the snapshotter and into the content store. And based on that pull flow, you can actually pull your image config, which becomes an OCI config, and then your root FS, which is a set of mounts. So here's an example of investigating the root file system. We can do CTR snapshot ls, and that will tell us what snapshots are and what container file systems are there. And we can see the relationships. If anybody remembers Docker tree, the command that was removed, we can actually do that a lot better because of the abstractions in containerd, and we can support it. And then you can actually take that and you can generate a mount command. So I can mount a container's file system without actually running a container, which is which is useful. So running a container is pretty similar, but I wanted to highlight part of the a la carte of containerd. Here we see an overview of the container service, which is a metadata service, and the task service, which is our runtime controller. And what actually happens is you give it a runtime config into the container service, and then when you start up a container using the task service, you use the mounts that are consumed from the snapshotter, and then you convert all of that down to the runtime config, and then you can run these various things. And this is loosely what it looks like on the back end, and just to give you kind of an idea of how the relationships might work. The same way we do pull. Here's how we do a start on or a run rather on a container. So we start out and we initialize. So we'll grab the images and snapshots. We'll build a new container file system into the snapshot store, which will fork off of an existing image snapshot, and then we set it up. So we build this container. We build an OCI config from that, and then and we get mounts, and then we actually start the container, and then out the arrow on the other end we have running containers, hopefully. All right, so I'm going to actually leave the demo to the end because these are rather short. But what I do want to show you a couple of. I've talked a lot about code and the client-heavy architecture, and I just want to show you how simple pulling an image, running containers is. It doesn't, like with Docker, you drive like an API, whereas this, I can go into this code and I can modify how everything happens. I can change everything. I could send out a tweet every time I pull an image or something like that. Somebody should do that. It'd be annoying, but cool. So the way this works is you start out and you create a client, and then you can add a defer for closing that client. Containerd is namespaced, meaning that it's very much like Kubernetes, and that I can run multiple different clients on top of it, and they don't conflict with each other. So, you can run Docker and kubelet next to each other, next to a builder, and they won't see their containers. And actually, Docker runs internal containers that you won't see in the regular Docker PS that are hidden by this namespacing feature. So then you declare this namespace, which is example, and then you just call client.pull. And then on the left side of the slide, we have a very similar command line example. So running a container is very similar. It continues to build on this Combinator API. So you use the same client that you declared before. Here we specify that we're going to use a particular image, which was defined off this screen. And then we can grab the specification directly from the image config. So that's actually, so I can actually define my own OCI generations. I don't have to use an image. I can define my own OCI generation process, or I can modify it with my own seccomp profiles or whatever you want. So you can build new combinators and really customize what's happening. And then we delete the container when we exit the function. And then so once we have a container, the container is like a metadata object, and we can use it to generate tasks. And so you call container.newTask, and that's your actual runtime handle. One interesting point that we did with containerd is we split out the concept of the metadata object and the actual runtime objects due to performance. And the reason for this is in Docker container, the container object is a super object, meaning it ended up having lots of locks. So anytime you want to modify it, you have to grab all those locks, and you have to deal with runtime state. Anytime you want to start a container, stop a container, you're grabbing all these locks. And we avoid this in containerd as much as possible. So the next step is you wait on the task, and that just calls a wait API, and that gives you back a channel. And then you can wait on that channel later. I think we have an example following this. And then you can call task.start. So this is very similar to when you like create a container in Docker, and then you start a container in Docker. And so you can do anything in between there and really hook into anything. So here, just like the last example, we have our task.wait and our exit status channel that we can actually use. And so what we're going to do is we can wait on the task, sleep a little bit, and then we can send it a sig term, which goes to the gRPC API and does the correct thing. And then we can actually wait on that channel and see. And then when this channel returns an object, it returns a little status object. And then out of that, you can get the exit code and the time of exit and that kind of thing. And then we have a fancy print statement. Another thing about this Combinator API is that you can do things like you can define your own functions that you can do on top of a spec. So this is an example of a Combinator that you can pass into creating a new container that will generate an htop config, and you can exec in and just run htop with a TTY. And there's all sorts of cool things you can do. You can define networking combinators like this. So here's an example of with host namespace, but we can do this in CRI. I believe there's places where we use similar combinators to actually hook into CNI. So a little bit about the project, since this is an intro. So we have a very well-defined release process, and we don't just say, oh, we use semver, and then argue about it later. We actually outlined exactly which parts of semver are done. We define which components are covered by the semantic versioning. We also define the life cycle of the releases. And you can read all about that here in detail, but I'll just give you a quick overview. So this is one component, which is called our support horizon. And it defines how long we have branches. So each branch has a state, end of life, which is old branches. We no longer backport fixes to those. We have active branches, which includes 1.0 and 1.1, which will be, we have this fancy, you can parse that and figure that out. But basically, we're saying, OK, well, we'll support it till the end of Kubernetes or the release of 1.2 or April 23rd, 2019, and we'll take whichever is the maximum of those, so that you're not left in a state where you're still running 1.1, but there's a security problem and it's still in use by Kubernetes or what have you. So, and this release process is defined in that release documents. We also identify which components are supported at this time, and this can change depending on users and depending on what actually people want. So like the gRPC API, we're considering stable. We won't do any backwards incompatible changes to it purposefully. So there could be changes that are accidentally happening, but we do consider it stable. The metrics API is considered stable, and we've actually versioned it for Prometheus, so if we do want to change it, we can add a V2 metrics or V3 metrics. Hopefully that won't happen. The other components right now are considered unstable, just because they're changing, and we're integrating with a bunch of systems, and we want to be able to make changes so that things work well. So the client API is unstable, although it's relatively stable, so don't be afraid to use it. The CRI gRPC API is considered unstable because it's still in alpha, and I'm not sure when that comes out of when that comes out of alpha yet. And then the command line tool, the CTR tool, is also considered unstable. And right now it's out of scope. I know people have more interest in that, so if you do, let us know. But don't deeply integrate scripts. If you're going to do production work with Containerd, I highly recommend writing your own Go code or building your own client. CRI tool is an example of that, and it works great. And because of the way because you really want to integrate with the target system rather than these low-level things. Like Containerd is really like a container runtime building system. So that really impacts how we do that. So the latest release was done the April 26th, I want to say, is that right? And so there's two big things. I mean, there's a whole big list. I suggest you go read these release notes. It's a really cool release. It's really cool to see the project taking shape. But the biggest thing is we merged in Kubernetes CRI support, so you can run Containerd with Kubernetes out of the box. And then we also there was a lot of requests for Snapshotter plugins, but we actually found that there's really only 3 that were really popular, and so we just added those rather than adding a complex plugin system that might break. And that's ZFS, AUFS, and a native Snapshotter. And then there's lots of other great things in this release, and I definitely go to this link and read it. The people worked hard on it. Just to give you an idea of how a kind of native plugin works in Containerd, this is how the integration with the Kubernetes CRI. There's a component called CRI within Containerd, and it actually interacts with the core services, which I showed you back on that diagram before. But it itself is within Containerd, and then influences the operating system, which consists of storage, file system, networking, so on. And then the core services actually control the runtimes. So going further with Containerd, again, here's the link to the project. Please let us know if you can help. We do need help with documentation right now, but there's other areas like bug fixes, tests, validation, that kind of thing. Again, check out the Getting Started guide. It's really good. Especially if you're a Go developer, it should be pretty straightforward to get started. And then porting, testing, test it on your architecture of choice. Let us know if there's problems with that. We do want better multi-arch support, and that should be coming down the pipe. We also do heavy upstream testing with Kubernetes Test Grid, and you can check out the status of that in Signode Containerd. So a couple of new talks. I talked a lot about snapshotters, and it's a complex topic, and it involves file systems and other fun stuff. I'm doing a talk on it in an hour, and I'll go over all the cool stuff you can do with snapshotted file systems. And then also we'll do a deep dive into Containerd, and I'll use this same slide set, but I'm gonna like push everything to the side and just like do mostly demo and kind of show you like, okay, here's CRI tool, here's how the pods look, or actually first we'll convert over from Docker to Containerd, and then we'll look at the pods and we'll play with them, and then we'll pull apart all the pods and look at the metadata storage, and then actually we can get down to the run C config. So that'll be a fun talk, and hopefully it'll be more interactive. So how much time do I have? 15 minutes? Okay, so I want to leave some time for questions, and then if there's no, or we can do some demos. Is there any questions right off the bat? Yeah, right here. So the question he's asking is, do we support Device Mapper? We have not gotten a contribution for Device Mapper, and I don't know if the Containerd maintainers are interested in it, but I don't see a reason they wouldn't take a contribution for Device Mapper. As long as it's well implemented, and we have a really good test suite too. So I'll talk a little bit about that in the snapshotters talk if you're more curious. Right here. No. The portable interface needs to be at the. I mean, yes, the APIs in Containerd will be portable from platform to platform, but there's so many differences between each platform and the way they implement containers. We had to implement a strict subset of what's between them. So, like for instance, our runtime model is definitely like platform agnostic, but if your snapshotters are not going to be that way. So you need to be able to interact with the file system and really be like it has to be local to the host. So it's not a remote API. So it's a little different from like say Docker or Pouch or any of those other projects like that. So I'm sorry, what was that? Yeah. Oh yeah. So it will come with things that are so the question was, will it come with components that are suitable for the various platforms? And the answer is yes. When I'm saying it's not platform agnostic, like Docker, for example, like you mostly interact with the API, whereas with Containerd, we say, well, you're going to be local to the host, and you can interact with the API as well as the host operating system. Does that clarify? Okay. Are there any other questions? All right, so let's do some demos. Okay, so running a container is pretty simple. I have an image here, and I mean, CTR is, it's kind of like Docker, as much as it can be. This is a whole bunch of specific OCI stuff. Like we have on the far left, we have our image name, and then we have the type of the image, and then we have information about what platforms they'll run on, and we actually have the total size. So, and then we can just take that. This is good old Redis. Redis is if Redis runs, everything works, right? So we can take that. And so in Containerd, we use fully qualified image names, so there's no kind of short image names, and this keeps things from being unambiguous in a lot of cases. So, but your container runtime could implement your own kind of image parsing. The actual image naming format is very, very simple. So just running here, really simple. Oops. So let's do a test 01. What do I do here? So there's running Redis, and you can see it's running. A few things about this. So remember that starting a container kind of data flow diagram we did before. That's what happened, and I can actually show you the byproducts of that. So we can do a CTR containers ls. And we can see, oh, there's my test 1 that didn't work because I didn't have access to create the FIFO. And then we have our test 02. We can also take a peek at the tasks that are associated with that. I think they've all exited, so they're not going to show up. And then we can actually look at the snapshots that were created as a byproduct of that. So I can do snapshot ls. And oh, wow, what's going on there? We have more hashes. We can see I was playing around with boo and bar and foo here. And then you can see the relationship. So across the top, we can see we have committed snapshots. And these 2 active snapshots are actually, those are the running container file systems. We can actually take this and we can look at the relationship here, and we can see that everything's descended from that one Redis image. And this hash is slightly different than what was up in the images ls for implementation details, but hopefully you'll believe me that this is the actual Redis image. So before I said that Containerd was namespaced, and I actually have a running Kubernetes thing on here. I think it's hurting though because I swear Kubernetes is actually running, and I think CRI Scuttle should work. So the problem is the Wi-Fi. Each time you go on the Wi-Fi, you lose the IP address, and I need to figure that out. I'll have it figured out by Friday, hopefully. But you can see all of the pods running, and I got Nginx deployments, some Hello World stuff, and then Calico, and a whole bunch of other stuff. And well, I mean, now you're wondering though. Okay, well, you said it's running in Containerd. Where are the containers? So oh, those are just my test containers. Actually, Containerd is namespaced, so all of these containers are completely hidden from the default namespace. So here's the actual Containerd containers that are implementing the pods inside of CryCuddle. So, all right, I think we're about out of time. Any questions on the demo? No? All right. All right, thanks, guys.